Hey guys, in this video, we'll be talking about Azure Application Insights, which is one of the most popular tools for developers that allows you to monitor the performance of your application. I hope you find it useful, so let's get into it. So in this video, we will talk about what is Application Insights and why is it used. Then we will talk about what data types can you collect using Application Insights. And then we will talk about how to enable Application Insights using SDKs or agents. Then we will talk about Application Insights features, which are data collection, availability tests, profiler, and Snapshot debugger. And then after that, we will talk about telemetry initializers and telemetry processors. And last but not least, we will talk about client-side monitoring. So what is Application Insights? Application Insights is an application performance monitoring solution, which means that it is a solution that monitors your running applications and collects data such as HTTP requests and how they handle those requests, dependencies, which are like database calls or calls to external APIs, exceptions, and many other data types that I will talk about later. So in this setup, you would have an Application Insights resource created on Azure, which acts as a data repository for your applications to send data to. So you would have your web server here, and you can have Application Insights configured as an SDK or as an agent, which is the codeless based. And then as part of your application, you would have probably a database and you would probably make calls to external APIs. And all of that data is collected by either the SDK or agent, which is then sent to the Application Insights resource on Azure, which acts as a data repository. And then you can do a lot of powerful stuff with that data that is already stored in Application Insights. So you could do some Kusto queries on it to generate some reports. You can also configure alerting on those data. So for example, if you have exceptions in your application, you can configure alerts to be sent, which are maybe sending emails to you and things like that. And you can also export that data to external data sources like Power BI, etc. So what data types can you collect with Application Insights? The first and most common data type is HTTP requests. And those are the actual HTTP requests made to your web server. So it is how your web server handles the HTTP requests. So from your get methods to your post methods to your delete methods and all of that stuff. So it can capture what are the actual requests, the response time, even request body in some circumstances if you can configure that and things like that. Next, you have dependencies, and dependencies are basically what your application depends on. So examples are database calls. So as part of your HTTP requests, your application depends on databases to get some data, okay? That is registered as a dependency. And also as part of your HTTP request handling, you can also be making calls to external APIs. And those calls to external APIs or calls to databases are recorded as dependencies. Next, we have exceptions, and those can be handled exceptions or unhandled exceptions. Those can be collected to Application Insights as well. Next, we have tracing, and those can range from your console logs to whatever logging mechanism you are using in your application. So traces is just another word for logs that you configure in your application. Then you can send things like custom metrics, which are basically metrics that you measure in your application, and you can send those as metrics to Application Insights. And then you also have things like custom events. So these represent specific information that you want to send from your application. So let's say when a user clicks a button, you want to register that as a custom event, and you can send that event to Application Insights to indicate that someone clicked that certain button. How do you enable Application Insights? The first and most common way to enable Application Insights is using an SDK. And this is basically when you download a library or a package that imports a series of code that will collect those requests, those dependencies, those exceptions automatically for you and send them over to Application Insights. Next, you have what we call agent-based or what we call codeless attached. And that is because all you have to do is just install an agent to collect data from Application Insights. So the first method with the SDK, you need to be doing changes to your code. So this is known as code-based monitoring. And this is not done during runtime because you have to recompile your code or rerun your code. But in the case of agent or codeless attached, you can do that during runtime because you're not making any changes to your code. so you don't have to recompile your code or rerun your code. I'm going to be demonstrating an example of how you would enable Azure Application Insights SDK on Node.js. So let's go to Visual Studio. So to enable Application Insights SDK on a Node.js application, you would have to install Application Insights package. Now, if you're using .NET or .NET Core, you have NuGet packages available for that. So everything I'm going to demonstrate is going to be applicable to any language or any runtime. Now, with that being said, I want to highlight that it is very important to import Application Insights as early as possible in your application, preferably at the beginning of your application. So in this case, the first import I am performing is Application Insights. Now, when you assign Application Insights package to App Insights variable, you would have to do some certain setups. Now, in this case, you have to call a series of methods to set up Application Insights. Again, I'm doing this as early as possible in my code. So the first method I call is .setup, which you have to pass an instrumentation key to, and I am passing that instrumentation key as an environment variable from my .env file. Okay. Next, I have a series of other methods to collect specific types of data. So in this case, I have set auto collect requests set to true, meaning that it will collect requests automatically without me explicitly calling methods or APIs to collect those requests. And the same is true for performance, exceptions, dependencies, console logs, etc. Next, I want to demonstrate what would happen if I make a call to my /products route. Okay, so what would happen here is I'm doing a database call to my MongoDB. So what I'm doing is I'm getting a list of all products from my database. And this is in order for me to demonstrate how that would get recorded as a dependency in Application Insights. Then, as part of that route handler, which is /products, I'm making a dummy API or dummy external API call to JSON placeholder.typecode.com/post/1, which is just a dummy API call in order to show you how that would get recorded as a dependency in Application Insights. Next, I'm adding a custom property to all of the data that I'm collecting in Application Insights. I'm going to talk about that a bit later on in this module. And then last but not least, I'm just sending back a JSON with the list of products that I retrieve from my database. Now, if I want to demonstrate that real quick in my browser, so now if I go to /products route, I will get back a list of products in JSON from my database. Next, I want to demonstrate how to retrieve custom events in Application Insights. So let's go back to Visual Studio. And if I go to the post handler under the same route /products, this is the route, or this is the API that allows users to add products. So what I'm doing here is I'm just retrieving the title and the price from the request body, and I'm calling track event method on telemetry client object. So the way I'm retrieving this telemetry client object is I'm first of all obviously importing Application Insights package to App Insights variable, and then what I'm doing is I'm calling .default client, and then I'm assigning that to telemetry client. Now, when you get access to the telemetry client object, you can call a bunch of different methods. So examples of these methods are track event if you want to track custom events. You can also call track metric if you want to track custom metrics, or you can even track requests if you want to track specific requests rather than relying on the package itself to automatically collect requests data for you. So in this example, I'm calling track event to record a custom event. So anytime a user adds a product to my database, I am calling track event to record a custom event called product has been added. And then at the end, I just save the product that the user created in my database, and I send back a message called successfully added product. So if I go to Postman to demonstrate that, if I click send on this route, I get back successfully added product. So in theory now in Application Insights, I should be able to see a dependency call because I added this product to the database, but I should also see a custom event being recorded because I'm recording that event whenever the user creates a product. Let's go back to the portal. So if I query for custom events in Application Insights, as you can see, I get 2 records with that custom event called product has been added. Next, I want to demonstrate how you would capture handled and unhandled exceptions in Application Insights. So let's go back to Visual Studio again. So I have a route called handled error. And whenever a user visits that route, I should throw an error called dummy handled error. And what I'm doing here is I'm catching that error and then sending it over to Application Insights. Now, whenever you're dealing with handled exceptions, or whenever you have a try-catch mechanism, as I have in this piece of code, you have to explicitly call track exception method. Just as we can call track event to register custom events in Application Insights, we can also call track exception method to record handled exceptions in Application Insights. So what I'm doing here is just I'm throwing an arbitrary error called dummy handled error. I'm catching it and then I'm sending it over to Application Insights. So if I go back to the portal and then if I query for exceptions table, as we can see, we can see a bunch of different errors here. But the error I am interested in is this one called dummy handled error, which represents the handled exception that I have in my code. However, as you can see, I can also see some unhandled exceptions in Application Insights. So the good news is that whenever you have unhandled exceptions in your code, Application Insights will actually capture those. And this is an example here. So I have an uncode reference error, which is Application Insights is not defined in my application. So that's just an exception that I did not handle in my code. But again, the good news is that Application Insights can also capture those. I've just demonstrated how to enable Application Insights SDK. But as I mentioned, you can also enable Application Insights through a codeless attached, where basically you just install an extension or an agent on your application, and that would not require you to recompile the code. So this is possible if you have your application running on either app service, as I have in this case, or even your applications that are running on premises or an Azure virtual machine. So what I'm going to do here is I'm going to demonstrate how you would enable codeless Application Insights on a Node.js application running on an Azure app service. So all you have to do, it's as simple as going to settings and then to Application Insights. And then all you have to do is just turn on Application Insights. So as you can see here, you need to make sure that this enable check is clicked. And then you obviously have to create, in this case, I'm creating a log analytics workspace. So basically with Application Insights, you have two modes. You have the classic mode, which is the legacy mode, where you don't have a log analytics workspace attached to Application Insights. But for newly created Application Insights, or the new way, quote unquote, you can attach a log analytics workspace to Application Insights in order to leverage extra features of log analytics. So this basically controls what the data repository is. It's either stored in Application Insights, in a data repository that you don't have a lot of control of, or in a log analytics workspace, which is a repository that you have a lot of control on. So this is something that I did not discuss previously, but in case you're curious, this is why you have a log analytics workspace section here. So you can either choose to create a new Application Insights resource along with a log analytics workspace, or you can just select an existing resource. And then if you click on apply, let's give that a bit of time. It should be very quick. And that's it. It's as simple as that. Now you have Application Insights enabled without having to rerun or recompile your application. So now let's talk about investigating your application. So you've done the hard work of enabling Application Insights SDK or agent or codeless based. Now the question is, how will you investigate your application? Now we have a couple of different blades in Application Insights that's going to help us do that. So the first blade that's going to help us do that is called Application Map. The second one is called Transaction Search. Third is the Failures tab. And last but not least, we have the Performance tab. Let me show you how those look in the portal. So starting with Application Map. Application Map is a tab that allows you to visually look at your application and the different instances that it's running. So for example, in my application, I have two different instances running, and I have an external API that I am calling, which is this dummy API. And I also have my MongoDB database. So with Application Map, it allows you to nicely visualize what you have in your application and all of its dependencies. And that includes your front-end code as well. So in this case, I have a React application, which is also shown here, and I'm going to demonstrate that in a bit. But again, it just allows you to visually view all the different components and how they interact with each other in your application. Next is Transaction Search. And this is where you're going to be spending the majority of your time on. Okay, and this allows you to specifically search for telemetry in Application Insights. So rather than performing queries in Application Insights under the logs section, you can just search for specific data in Application Insights. So in this case, if I just click see all data in the last 24 hours, I can search for specific types of data. So for example, I'm looking for request data, okay? I can search for that and I'm gonna get some results, okay? I can search for a specific error message, let's say. So let's say I have customers complaining about a specific error message. I can also search for that here. So again, from the name, it's called transaction search. It allows you to search for the transactions of your applications or the different type of telemetry in your applications. Next, we have the failures tab, and the failures tab is very similar to the transaction search and the performance tab. It's just a tab that allows you to delve deep into the failures of your applications, or in other words, the exceptions. So whether those are handled exceptions or unhandled exceptions. Again, it's just a nice view for you to delve deep into the failures of your application. Next, we have the performance blade, and this performance blade is also one of the blades where you'll be spending the majority of your time on. So this allows you to check the duration of your request. So you can filter by the longest running duration of your request. So let's say your customers are complaining about your slowly performing application. You can go straight into this performance tab, and then you can investigate certain calls that are very slow. So for example, in this case, I have this get/products route that's taking a long time as per my standards. Okay, so I can click on that and I can delve into sample calls that customers made. So if I click drill into samples, I can see 3 samples in this example. So if I click on one of them, the suggested one, I can see the end-to-end transaction details. And as you can see, the total duration is 309 millisecond, okay? But that 309 millisecond also consists of other dependency calls. So as part of the get/products route, my application is making a call to the database to retrieve a list of products, but it's also making a call to the external API before giving back the response to the user. So my call is not just handling this specific computation. There's also a dependency call to my database, and there's also an external API call to this dummy API called JSON placeholder, okay? Now, the big misconception that customers think or users of Application Insights think is that those two here should add to each other, and that's not true because there is some computational time that is spent in your actual application to give back the response to the user. However, in addition to that computational time, which might be just 10 milliseconds, there is some additional time like calling the database and the external API. So those two things do not necessarily add to 309, okay, but they comprise part of the request itself. Let's get into some extra Application Insights features. And the first feature I would like to talk about is availability tests. And with availability tests, you can configure tests that pings your application via an HTTP request. And depending on the response of that HTTP request, you can trigger certain alerts to be fired. So this is very useful if you want to test whether your application is down. And then if your application is down, you can undertake certain actions by configuring an alert to be fired when the availability test fails. So let me show you how that looks like in the portal. So under Investigate, you would have this availability tab. And with the availability tab, you can click on Add Classic Test to create an availability test. And then you would give it a name, and then you would give it a type. So URL ping is basically just a simple ping to your application, but you can also configure what is known as a multi-step test, meaning that you want to test a certain workflow in your application. So a user clicks this link and then clicks that link, and you want to test the whole flow and whether that is successful or not. In this case, I'm going to keep it simple by going with URL ping. And then you can obviously enable retries for the availability test failures. So just to allow the test to retry in case there is a failure. And you can also parse the request if you want to choose to. And then you could choose the test frequency. So in this case, you have 5 minutes and then every 15 minutes as well. And then you can configure what is known as test locations. So if you want to test your application from different locations, that's also something that is recommended because sometimes the test can fail from a specific application, especially if you have firewalls configured and things like that. So it's always recommended to have multi-location test just to really verify whether your application is down or whether it's just a failure on a specific from a specific location. And then here you can choose what is known as the success criteria. So You can test what is known as a timeout. So it's not necessarily a failure to respond to the ping request. You can also configure a timeout. So basically, if it takes 120 seconds in this case for the application to respond to the ping, you can also configure a test based on that. And then you can also test based on the status code. So if you want to test whether you get back 400, you can also do that. And then you can also test for specific content matches. So if the content matches a specific thing that you write here, then you can configure tests based on that. Next, we have Profiler. And with Profiler, it provides performance traces for your application to investigate things like slow responses. So essentially, all it does is collect extra traces in your application, but those traces are super detailed and they allow you to see the time spent in the actual code itself. So it gets you down to the exact code. Now, you typically trigger it for a duration of a couple of minutes while reproducing the issue. But again, it's very useful for troubleshooting purposes because it really gets you down to the exact code. Unfortunately, I won't be able to demonstrate that because this is only supported on .NET and not on Node.js. But I wanted to bring this up because this is a very useful feature to have that we have in Application Insights. Next, we have Snapshot Debugger. And from the name, it is just a snapshot of your application at a specific point in time, and it is captured whenever an exception occurs. So if you want to enable Snapshot Debugger, it takes a snapshot of your application whenever an exception occurs. Now, this snapshot shows the state of the source code at that specific point in time, including all the variables at the moment that the exception was thrown. Again, this is very useful for troubleshooting purposes to understand the state that your application was in before the exception was thrown. And last but not least, we have what is known as smart detection. And these are a bunch of preset alert rules, some of them behind the scenes, which we do not see. And they alert you whenever anomalies happen in your application, meaning something unusual. So we have two types. The first type is called failure anomalies, which can be found from the alerts tab and notifies you whenever there is a sudden spike of failures in your application. So if I want to show you on the portal, you would go to the monitoring section and then to the alerts tab, and then you would click on manage alert rules. And as you can see, you have an alert called failure anomalies. Now, this alert is created by default. So this is not something that I created, and it is there by default. So what you can do is you can configure this alert mainly to change, for example, the action group. So by default, this will, when this alert fires, it will send an email to the subscription owners. So this is the default action group. But of course, you can configure, your custom action groups, whatever they are. So this is, again, something that is that can be found under the alerts tab. And this is what is known as failure anomalies. Now, the other type is known as performance anomalies, which can be found on the smart detection blade on Application Insights. So if you go under investigate, and then you go to smart detection, and then you go to settings, those are what are known as performance anomalies alerts. And this is not something that you can see under the alerts tab, which is for the failure anomalies case. Now, in this case, if you want to modify the action group of the preset alerts, which are behind the scenes, you would have to use an ARM template in this case. Next, let's talk about Telemetry Initializers. With Telemetry Initializers, you can configure your Application Insights SDK to enrich telemetry. And this is very powerful because you can add your own custom telemetry to whatever type of data you want, whether it's requests, dependencies, exceptions, etc. And this is very powerful for developers who want to customize things. So this is a very basic example that I have in this slide. So in this case, I have custom dimensions, which are set by default, and I don't have anything customized here. But if you look on the right-hand side, I have a custom dimension or a custom property called test. And this is a custom property that I created using the Application Insights SDK. So again, this is a very simple example of a telemetry initializer that is used to enrich telemetry. And you have a bunch of different examples on the Microsoft public documentation. So make sure to check those out. Now, if I want to show you very quickly how I did that in my code, let me go back to Visual Studio. And then if I go to the /products get route, as you can see, I have this telemetry client object, which I can call common properties methods on to define what custom properties I want to add. So in this case, this is the custom property that I want to add. So again, The same way you would call track event method, for example, you can call common properties here to add common properties to my, in this case, any data type. So this custom dimension or custom property will be added to all kinds of data types, whether they are requests, dependencies, etc. So this is a very simple telemetry initializer example. Then let's talk about telemetry processors. And telemetry processors are used to filter telemetry. And the perfect example is what is known as sampling, which is very common in application insights. And it is very important to understand because there's a lot of confusions around sampling. So sampling in a nutshell is used to reduce logging. Okay, so for example, if you get 1 million requests in your application, you don't want to analyze every single one of those requests. So sampling takes a percentage of those calls and then sends them over to application insights. Now, essentially we have two types. The first is adaptive and fixed sampling. So those are kind of combined into one, and both are set in the SDK itself, so in the code. And adaptive adjusts the volume based on how much telemetry you are sending, and fixed sampling is set at a fixed rate decided by you. So I want to demonstrate how I would set a fixed rate sampling, which is supported in Node.js SDK. So if I go to Visual Studio, and notice I have this line. So I'm calling .config.sampling percentage on the telemetry client object, and I'm setting this to 33%. So I'm taking 33% out of all of the telemetry I am collecting. So this is a fixed rate sampling. Now, the other type of sampling is known as ingestion sampling, and this is done in the portal itself and is typically used to reduce billing charges. So if I go to the portal and under configure, you have the usage and estimated costs blade. And then if you click on data sampling, you can set the sampling on the portal level. This is what is known as ingestion sampling. Again, this is typically used if you want to reduce your application insights costs. Now, you can set that to all data, meaning if it's set at 100%, everything will be collected. And then you can obviously reduce that. So if you set this as 50%, that means 50% of telemetry will be dropped. Now, to quickly explain how sampling works, because this is very important, the way the algorithm decides which data to drop is by establishing relationships. So, for example, if your application has many failed requests included in the sample, any traces associated with those failed requests will be combined with them and will either all be dropped or retained. So you will always see the request along with its associated telemetry items or none of them. And that decision is made based on a property known as operation ID. Now let's talk about client-side telemetry. So with all the previous modules, we only spoke about server-side telemetry. So things like requests, dependencies, which are database calls, calls to external APIs, and exceptions. So everything we spoke about is about monitoring server-side code. However, just as you have your main application running on the server, you typically have another application written in JavaScript, whether it uses React, Angular, or just plain JavaScript. That application lives in the browser. So it's a different application. It's called the front-end application. But guess what? You can also monitor that application that lives inside the browser as well, and not just the server-side code. So just as we have an SDK specifically for server-side monitoring, we also have front-end SDKs to monitor your front-end applications. So what can you monitor with client-side application insights? So the first thing you monitor is what is known as AJAX requests. Now, AJAX requests is a very fancy term to imply HTTP requests that are being made from your front-end application to your back-end server. Those are known as AJAX requests. So let me give you a very quick example of a very simple front-end application that I've written. So if I go to the browser and I go to localhost 3000, this is where my front-end application is hosted. And it's just a very simple application. All I have is just a button that does an AJAX call or an API call to my back-end server application. So again, two different applications. One that is living inside this browser, which is the front-end application, and the other one is the server-side application, which is what I've been demonstrating in the previous modules. So if I click on get products, as you can see, I get back a response from my back-end server. Okay, now the API call is localhost 8080/products. Again, this is what my server-side application is living in, okay? This is what is known as AJAX request, and this is the most common type of telemetry that you can collect with client-side Application Insights SDK. Now, the other type of data that you can collect is exceptions. So again, just as you can have exceptions in your server-side application, you can also have exceptions in your front-end application. So this is something that you can also monitor. And next, you have page views. So you can monitor how many times a user visited a specific page. Again, very useful for marketing purposes, for example. And last but not least, you can also monitor browser timing. So how long does it take for a certain page to load? And let me show you how I did all of that in my very simple front-end code. So let's go back to Visual Studio. Now, this is a very simple React application. You don't need to know React. I'm just doing that for demonstration purposes. So in this case, I'm importing the library, and then I'm creating a new object out of the package that I imported. And then I specify the instrumentation key. And then I call load app insights method. And in this case, I am calling another method called track page view method, which I have to explicitly call if I want to track the page views, which again is an example of a type of telemetry I can collect with client-side application insights. So if I go back to the Azure portal, and then if I type dependencies where SDK version is JavaScript, now the reason why I am typing that is because I'm specifically looking for dependencies data with client-side JavaScript, because again, I have dependencies with server-side Node.js, and I have dependencies with client-side JavaScript SDK. So two different SDKs, because why? We have two different applications. One is the front end and one is the back end. So if I run that query, I get those results, which are of type AJAX. And again, this is how you can find out the AJAX calls that your front-end application is making to your back-end application. So it is under the dependencies table. This is if you want to look at the AJAX requests. Now, if you want to check, for example, front-end exceptions, you would type exceptions, and then you would keep the SDK version as JavaScript, because I'm looking for front-end exceptions, not back-end exceptions. What I'm doing something wrong here. I am not actually. So as you can see, it's giving me a couple of different exceptions, and those are all client-side exceptions. So this is nothing to do with my back-end server exception. Then you can also monitor, for example, page views. So if I type page views and I run that, again, I can see a couple of different page views. Again, it's unique to each user, and you can find things like the duration, for example, of a specific URL and things like that. And then you can dig deep into what is known as browser timings. So with browser timings, again, you can see how long it took for a request to fulfill, but it gives you extra information, for example, about the processing duration, so how long it took to process this request, and it can dig you deep into, for example, the network duration. So again, because request comprises of different durations. So you have the processing durations, you have the send duration, and a network duration. So the browser timings data type is very useful for you to dig deep into why your browser, for example, is taking a long time to serve your front-end application. So this is pretty much it with client-side JavaScript. Again, this is just a different SDK, another SDK that's used for your front-end applications.